Hello, this is my egg catcher design presentation. My name is Christopher Shkreli. Here I am on the right holding my egg catch structure on May 3rd, 2021. Little background on this project. We were tasked to create a structure to catch a minimum of a 60-gram egg from a minimum height of 6 feet. The structure material that we were allowed to use were drinking straws, which were 7 3/4 of an inch, and a masking tape. A little guideline was we couldn't use more than 250 straws, which was the amount in the pack. And our end goal was to create a lightweight and maintainable structure that was both durable and obviously caught the egg with no damage at all, no cracking or any permanent damage to the egg. Another guideline that we were given was it should not be a mattress type of structure. Here we have my initial design. A little disclaimer here. This is a more along, if we were looking at it as an alpha and a beta design and then a final design. This is more of a beta design that I had finalized in CAD. It took me a few go-arounds and ideas, and I came up with this design as a kind of a beta. As you can see here, I didn't have any of these side stabilization trusses, which are, I can point to them right about here. These are the side stabilization trusses. I did not have those on. All we had was this V catch area, which I guess you could call at the time an X catch area. This was not here, and these are just little amendments to prevent the egg from falling out either side. And these at the top are retention straws, which I were pre-stressed in order to allow an egg to fall in, but they were pre-stressed downwards to allow the egg to fall in, but not to allow it to bounce back out. The number of straws used in this iteration was 77. The estimated amount of tape used was 150 centimeters. Total weight estimated of this was 0.4 newtons, and the overall mass was 41 grams as calculated by the weight and or the mass of the tape and straws. Here we have the initial design video. I'm going to play through it first, and then we will go through slowly each portion, and then I analyze different parts of it. Okay, so a few different features here. As we see the egg coming in, kind of bends that straw, the retention straw, out of the way a little bit. It doesn't really do justice to what I was explaining, but in the final design video, you'll see that in action. As we see the egg come in, something to note is many resources that I saw during my research stated that the strongest part of an egg is the bottom portion. If you look here, this egg is coming in on its side, and if we determined that the bottom portion would be the flatter up portion of the egg, and the top was that more pointy conical top point. This was kind of on its side here. So as we see it come in, a lot of elastic deformation here. All of these straws working together to transfer that force of the egg in free fall down to the ground. Obviously have a very solid ground below, concrete slab, and we could see how this egg is just traveling down, swings back up a little bit, and see right there we have an example of the straw that is pre-stressed in the downward direction and not in the upward direction, bouncing that egg back down towards the V-catch area. And to just get into it a little bit further, this is the V-catch area, this center portion where all these straws are in more of an X shape, but if you count the top, it's a V catch area. Additionally, you could see how if these side stabilization trusses were not here, that this structure could possibly have tipped over during this fall, and most certainly during the final design video. This first iteration definitely met my expectations, and I was quite pleased actually. This video here was after, I would say, approximately 20 to 25 drops from about 6 feet. So a lot of these straws were very stressed. Some of them to plastic deformation, where they were actually beginning to crack and needed replacement. But I kept pushing through to see what would happen. A few things that weren't caught on this video that occurred after I kept testing to see what was the breaking point of this structure. After a certain amount of drops, some of these straws in the V catch area became dislodged in the bottom, or actually only on the bottom portion here, which allowed the egg to slip through and crack down here or down here, depending on which side it hit. And that was what we're going to get into next. So here's our front before and after. This is the before of the this structure without these V-catch area reinforcement beam and truss. So we have a solid beam reinforced with another straw slid in through the center to make it a little bit more stiff, and mechanical connections on either side right here and here, which are basically just folded over straws that are stuck in, and there is no tape here. This is friction holding these straws in. And then we could see that from the front before and after. You can see on the top a little bit more of what I'm talking about. Here we can have, just in the center here is just a woven in straw, again doubled up. There's another straw that was stuck inside of it to make it a little bit more stiff and rigid, and to help it prevent it from plastic deformation. Here we can see the truss design here in the center. These were cut at an angle, taped down, and then brought down to these corners and taped down as well. There's some mechanical connection here. These are kind of, if you can see, bowed a little bit to cause some stress to keep it in that corner, and provide some stability towards this V-catch area, a little bit more of a spring. And as I was saying, here's the top. So we see here, this is the after. Obviously, all of these were before and after. Here you could see how if one of these straws left out would leave enough of a gap for the egg to push through and fall and crack on this lower portion where it was open. This has taken care of that issue completely. I hadn't had any issues after this redesign where this beam along the outside pushed on the backside of these straws, and I did not fasten it anywhere on here to allow for these trusses to move up and down with the V-catch area as it's stressed and faces elastic deformation. Here's the redesign video. Again, I'll play it and then we'll come back through it afterwards. Okay, so as we see, it comes in on the side here. This really displays how these straws, these retention straws, are pre-stressed. Comes in on the side. You can see the stress on the side stabilization trusses as it comes in. We actually did have right here in the center a straw become dislodged from the top, but those beams on the side provided enough rigidity that the egg was not able to push any of the other straws out of the way, and allowed it to maintain inside of that V-catch area. Again, comes up to the top, not really displayed there. And there was more in the initial video of the retention straws pushing it back down towards the center. Very happy with this design, and it was a very, very durable. So in conclusion, final mass of 47.05 grams, final weight of 0.46 newtons, final straw count of 87, and a final amount of tape used, which was estimated to be about 170 centimeters. This structure that was designed meets and exceeds well beyond the outline requirements of the project. It was able to maintain a light weight, which if you consider the weight of the object or the mass of the object falling being 60 grams and the final mass being 47.05, it's less than the actual weight or the mass of the object falling, and is very durable, as stated. This structure was well into the 20 or 30 egg drop range, and then obviously very maintainable. I swapped out a few of these straws from the initial drop in that V-catch area to allow for a little bit of fair testing this go around. I'd like to thank you for your time and allowing me to participate in this project, and I hope that you have a great rest of your day.